Hey guys, well, G0602 project's coming along. I got the nice little decal that I had made for it, and this is what my interpretation of the G0602 CNC would be had Grizzly made them. And so far it's turned out pretty good. So in the last video you saw I got the mounts complete, and I've got the stepper motors just running, and that was a big accomplishment to get it to that point, and I wanted to get to that point before I put it in place, so you know, if I had to move around I could easily do that. So it's all ready to go now. Now we just need to configure Mach 3. Okay, so the first thing we're going to do is we're going to configure our stepper motors. So you go up to configuration. You can select the native units. I use inches, but I know a lot of people use millimeters. Go ahead and set that. That's the very first thing. It also, I believe, when you install Mach 3, it asks you if you want to set it up for English or metric. So do that as well. Or you may have already done this. So go to configure, ports and pins. Port 1 is the port we're using. So it's enabled. I don't have a second DB25 board, so we're not going to be using port 2. The kernel speed is set to 25 Hertz. That's what it was. I didn't change that. I just left it. And none of this stuff is turned on or checked. The next tab is your motor outputs. And if you go back to the wiring schematic, you will see that the X-axis you need to check enabled, and we used pin 2 for the step and pin 3 for the direction. And then on the Z-axis you also want to enable it by checking it. For the step we used pin 4, and for the direction we used pin 5. Now the direction low active, if you check or uncheck this and the step low active, it's going to dictate which direction the stepper motor goes, so you have to play around with that. And if you end up going, if you're trying to go forward and your stepper motor goes backwards, then you can play around with that. And there's also another spot that you can reverse the direction as well, but one way is here, and that's it. That's all. We don't have the spindle connected in this as of yet in this format, but we will later. So that's it. Those are the only two stepper motors we need to worry about on the motor output tab. The next tab we're going to look at is the input signals, and we have our X home and our Z home enabled. And our X home, if we go back and look at the schematics, we used port 1 and pin number 11 for the X home, and pin number 13 for the Z home. You want to check active low, because these are normally closed switches. That's the way we wired it up, and when the switch opens and gives you a low signal, then the switch is activated. So that's the way I have them wired up. I think it's better to wire them up that way. The next item we're going to configure is our tachometer, which is our index, and that we want to check that off so that it's enabled. Port 1 and pin 15 is what we're using. The next item is our e-stop. We want to check it to enable it. Again, port 1, pin number 10, and this is going to be an active low signal as well. So we have that checked off. And that's it for our input signals. Make sure you hit apply before you exit out of this or make any changes. Make sure you hit apply. Our output, we don't have anything set up for our output. The spindle setup. Right now we're not using the spindle relay, so we have that checked. Right now I don't have my coolant connected, so I have that disabled. Right here where it says motor control, use spindle motor output. Now, even though I'm not using that at the moment, if you do not check this, your tachometer will not work. So let me show you what I mean. I'm gonna click OK and get out of this. I'm gonna power up the G0602. I'm gonna hit reset. Just go to manual here, and you can see that I'm not getting any spindle signal right here. If I turn the spindle on, not getting any signal. But if I turn on motor, use spindle motor output, even though I don't have that hooked up, now if I turn the spindle on, now you can see I have my tachometer. And this number here, 255, 254, 255, is reading the same thing as my tachometer. So, sorry, I'm trying to get the camera right away here. Okay. So you have to have that checked off. Let me turn this back off right now. You have to have, in configurations, ports and pins, spindle setup, you have to check use spindle motor output in order for the tach signal to work, even though you have the spindle relays disabled. Okay, in turn options, the X mode. Now, radius or diameter. I'm not real sure which is the best route to go. Diameter mode would be useful if you're turning, say something down to 1 inch in diameter. If you're in diameter mode, then your DROs are going to tell you that it's 1 inch diameter, and when you measure it, it's going to be 1 inch diameter. If you're in radius mode, then you'll be moving 1/2 inch, and you'll have to do the math to figure out if you have the correct diameter. I think for the most part, most people go with diameter mode, but I'm not sure. So I'm going to give radius mode a try and see if I like it. If not, I'll switch over to diameter mode. If you look inside the Mach 3 manual, it gives a better explanation of this than I can give. And the choice is yours on that. This reversed arcs in front of post, I've got that checked, and I believe it's because I am going to be cutting in front of the spindle instead of behind the spindle, but I'm not sure on that. Don't quote me on that. I'll have to double check that. So that's it for ports and pins. The next thing is our motor tuning. Okay, for our motor tuning and setup, we need to set up our steps per unit. So most of the modern stepper motors are 1.8 degrees per step. So you divide 360 degrees by 1.8 degree, and you come up with 200 steps. So that's where we get the 200 steps per revolution for our motor. Our stepper motor driver, my particular driver is a DQ542MA, and the lowest pulse per revolution that it outputs is 400, which is half step. So what you have to do is you basically just multiply the 200 by 2 to get your 400, and then we need to figure out how far we're going to travel per revolution of the ball screw. Now my ball screws, I'm using two different types. I'm using metric, and I'm using RM 1204s. The 1204 represents 12 millimeter in diameter and 4 millimeter pitch for our threads. So I need to convert that to inches because Mach 3 uses inches. There's 25.4 millimeters per inch. So I divide the 25.4 by 4 millimeter, and I get 6.35 threads per inch. So you take the 6.35 threads per inch and you multiply it by the 400, 200 times 2 for half step, and then you multiply that by 6.35, and you get 2,540 steps per unit. So that's for our x-axis. So we have that set up, and then we need to work on our velocity and our acceleration. What you want to listen for is good acceleration, because this is a lathe and we're going to be doing threading. So we want our x-axis to retract from the spindle, from the workpiece. You want it to retract fairly quickly because you're going to be threading. We want it to move smoothly, and we don't want it to make any weird noises or bind or skip any steps. Now this is full speed, and you can see it sounds good, it's smooth, it accelerates well. If you lower the acceleration, I have mine on 45, but if you change this to 5, listen to the difference. And if you go down to say 1, it takes a couple seconds for it to get up to full speed. Well, you can see that threading, that's not going to work very well. Now maybe on your z-axis on a mill, that'll be okay. But for this, it's not going to work real well. So I'm going to bump that acceleration up to, let's say, I think I had it on 45, but let's just set it to 20. And that moves in and out quick enough so that as I'm going across and threading, I think it'll be just fine. So now I've got that where I want it. The step and the pulse, direction pulse, I left those at 0. I think they're fine. So I've got my velocity around 64, 65. You can start out at 100 and work your way around. This is a smaller 280 ounce motor, and different motors, different size motors, they're going to give you different results. So you have to just kind of play around with it and find the happy medium. Make sure you're not skipping any steps. Make sure it doesn't make any weird buzzing sounds, and I think you'll be fine. So make sure you save your, every time you make a change, make sure you save the axis. And then our next is our Z axis. And this is a 425 amps stepper motor. And we need to figure our steps, which I've already done here, but it's basically the same math. The stepper motor, the Z axis ball screw is REM 1605, meaning it's 16 millimeters in diameter and a 5 millimeter screw pitch. So we do the math again with that. It's 200 times 2 because we're half stepping, which gives me 400. And then if you divide 25.4 millimeters by 5, you get 5.08 turns per inch, or threads per inch, I'm sorry. And you multiply that by 400 and you get 2032 steps per unit. So that's the math on that. Again, make your changes to your acceleration and your velocity. If you can start out with 100 and see how that works. Make sure you save it. Okay. See how it sounds? I'm getting a little weird noise. Okay, don't like that. So I want to move that down to, let's say, 75. And save it. Give that a shot. That sounds good. Let's drop it down to, say, 10 more and just see what it sounds like. So that's good. So we've got our motors tuned. We've got our threads per inch set, and we'll check these later. Our spindle, because we've got the spindle set up, it gives you a spindle tab here, otherwise it wouldn't. But right now we're not going to worry about that because we don't have it hooked up to a spindle. So that's pretty much it for the motor tuning. Okay, the next item under configuration is general configuration. I only made a couple of changes here. Under tool change, I have stop spindle and wait for cycle start. This way, if I'm calling for a different tool, it'll stop and I can change out the tool holder before it starts again. Also, active plane of movement. I want to make sure that X and Z is checked here. And I believe those are the only two items that I changed as far as general configuration. Everything else is pretty much default. Auto screen enlarge. If you open up your Mach turn and it's in a small window on your screen because your resolution is real high, if you'll check this auto screen enlarge, it will automatically enlarge Mach turn to the appropriate size to fill up your whole monitor. Alright, so that's under general configuration. The next item is our system hotkeys, which I'm not using. Homing and limits. Now you can set up your system hotkeys however you like. This for your jog, but I'm just using the default keys. The next item is our homing and limits. Now you remember I told you that you could change the direction of your motors in the homing and limits, and right here is where you do that. If you need them reversed, you just select it here. This is your soft limit maximum and minimum. My minimum is going to be 0 because that's where my home switch is going to be. And then I'm moving my axis in a negative direction from home. My X moves 11 inches of travel and my Z has 18¼ inches of travel. Auto zero the DROs once it hits home. And right here, the speed in which it references, you need to change this. If you leave it on 1, it will go so slow you'll be an old man before it homes. So make sure you change this to about 25 to 50%. The slow zone I have set up for 1 inch. This is this tells Mach 3 to slow down when it gets an inch before one of the soft limits. And so that's it for homing and limits. The next item under configuration is the tool path. I don't have any of this changed. I just left it all default. If you like any more information on this, you can read up on it and see if there's something in there that you might need to change. I haven't seen anything yet. The next axis is our slave axis. We don't have one. Backlash. If you have backlash on your axis, maybe you're using lead screws instead of ball screws, or for some other reason you have some backlash, this is where you would input the amount of backlash you have to try to get rid of that and compensate for that. I don't have any problems, so make sure you enable it if you put anything in here. Okay, the next tab is our plug-ins. I don't have any of those right now, except for whatever default is. Spindle relays. Set your spindle relays up for your lathe. Mine has 3 spindles and a maximum of 2,000 RPMs. So you just put the pulley number in there and the minimum and the maximum. Set that up. And safe Z setup. I don't have that set up as of yet. I do have it set up on my mill, but I'm not sure how I'm going to set it up on the lathe yet. So we'll see how that goes. And the last is save all the settings. So once you make all your changes, you want to make sure that you save your settings, and then you should be good to go. So those are all the inputs, ports and pins. That's all set up. And we can go to our manual here. And let me power it up. Alright, we're powered up. And up here in the top left hand corner is a little stethoscope. That's our diagnostics. And here we can check to verify that our home switches and all the inputs are in the correct position. So we have our X home switch. You can see it blinking when I energize it. Our Z home switch. We can check our spindle to make sure that it turns on. And I can turn the spindle by hand here, and you can see that the index is going off and on. So I know that input is getting in. If I type in M8, that's my output 4. That is for my flood coolant, so I know that that output is working. N9 turns it off. So that's pretty much it. Turn the spindle off. Again, you have to have this set up, even though it's not actually controlling the spindle. You have to have it set up in order for the tachometer to work. So now that we've got everything set up, we can turn on our spindle, and we can see our RPMs increase here. We're getting our pulse. It's going to pretty much stay steady. But we have 254, 255. That's what we're reading here. I'm a little concerned about my magnetic proc switch that I'm using for the tachometer. We'll see how it does with threading, but it's pretty consistent now, so we'll see how that goes. And then you also see that the spindle's on. But that's pretty much it for your setting it up. Now we just need to check and make sure that our steps per unit are actually accurate, and we'll do that in the next video. So thanks for watching. Please subscribe to the YouTube channel and have a great day.